but we're going to be looking at assignment 16. So this is an interesting assignment, and by interesting I mean it's kind of like at first glance it can be a little confusing because I'm asking questions a different way than I normally am. And then like at second glance, it's pretty easy because I'm asking stuff that your brain kind of already thinks it has an answer for. And then it's harder because some of the things your brain automatically goes to are wrong. So maybe you can answer all three of these just off the top of your head. That'd be cool. But even if you can't, I'm going to go through every last thing completely fully. So go ahead, read through the question, and you know, feel free to come up with your own intuitive answers, but then compare them to what we get at the end. So we have ball A and ball B. They are identical. They are released from the height shown, so 5 meters and 10 meters. We're going to ignore air resistance. So compare their initial energy stored gravitationally using the ratio EgB over EgA. Basically what I'm asking is how many times bigger is B's gravitationally stored energy compared to A's? So let's think about this. If we're going to take the fraction EgB over EgA, well, we know that Eg is just the mass of B times 10 kilograms, excuse me, 10 newtons per kilogram times the height, which we know is 10, divided by the mass of A times 10 newtons per kilogram times a height of 5. Well, let's look at this. These two obviously cancel out. They're the same, so that's nice. MB and MA, well, if these are really identical, then they should also cancel out. They're the same. So ultimately, our fraction just ends up being 10 over 5, which is just 2. So what that means is that ball B has twice the energy stored gravitationally as ball A. Maybe that's obvious, and that's great. Cool. Compare their accelerations while in the air. Okay, so here's the first place where intuitive things can go wrong. Hey, look, ball B is twice the energy. Shouldn't that mean it accelerates twice as quickly? No. Acceleration for something falling is always negative 10 meters per second squared. That will be the acceleration for B. That will be the acceleration for A. So what's the ratio between them? 1. They will have the same acceleration. Ball B will accelerate just as quickly as ball A. It does not matter that ball B is twice the energy. All right, last one, and this is the tricky one. Compare their velocities just before each hits the ground. So let's think about what's going on here. We have twice the energy in ball B, but we know that it's going to accelerate just as much. So usually the wrong answer I get is either the same or double. And I can see intuitive arguments for both, right? Hey, this one has twice the energy, it should be going twice as fast. That's an intuitive argument I can understand. Or, hey, they both accelerate at 10 meters per second squared. Shouldn't they both hit the ground at the same speed? Again, that's an intuitive argument that makes sense. Let's go through our model and see if we can figure it out. Velocity is related to energy stored kinetically. So let's go ahead and think about this energy stored kinetically thing. If the ball has some energy stored kinetically, where is that energy? Where was that energy before, right? If ball B is just about to hit the ground, all this energy it has stored kinetically used to be stored gravitationally. So if we know the amount of energy we have stored gravitationally, then we can use that to figure out how much energy we have stored kinetically. So ball B, we know, has twice as much energy stored gravitationally. Ball A doesn't have as much. We saw in the first question that it doesn't have as much energy stored gravitationally. So it's only going to have half the energy stored kinetically as well. That should not be a G. Oops. So how do we deal with this? Well, I know that the kinetic energy of B is equal to twice the kinetic energy of A. There's no way that we could get around that. So if I want to find out the velocity of A and the velocity of B, what I'm going to do is this, is I'm going to I'm going to go ahead and expand both of these, right, in using our formulas. So 1/2 mass of B times velocity of B squared is equal to 2 times 1/2 the mass of A times the velocity of A squared. So now we see, when we expand this out, we can see the velocity of B and the velocity of A. Now there's all this other junk going around here, so it's tricky to see how we would compare them. Our goal is, again, to get this velocity of B over A. So that's my job. I'm going to rearrange this to try to figure all that out. So first thing I'm going to do is I'm going to cancel out things that I know are the same. This half is the same on both sides, so I'm just going to cancel it out. And we saw before, the mass of B and the mass of A have to be the same. By the way, a little note was, I never give you the masses. Why don't I give you the masses? Well, the mass actually never played into any of these problems. So ultimately, we end up getting then is that the velocity of B squared is equal to twice the velocity of A squared. All right, well, let's take the square root of both sides. Oops. So the left side becomes VB. We're going to ignore the plus minus thing because we're physicists and we get to ignore things that don't seem realistic. Too bad for your math teacher. And then root 2 VA. So if I solve this for VB over VA, which is what was requested of me, I can do that. VB over VA equals root 2. Which, if I remember correctly, is like 1.4. Ball B will be going root 2 times faster when it hits the ground. Twice the energy, but only root 2 times the velocity. So that's so like I said, I usually have a lot of students saying 2. Well, it's not 2, it's root 2. And that comes from the fact that energy stored kinetically is related to the square of the velocity, not to just the regular velocity. Compare that up here with the height. This one has double the height, so it has double the energy. Well, this one has double the energy, but only root 2 the height. All right, everyone, please let me know if you have any questions. But yeah, that's about it.